Good morning to all of my students. Myself, Mr. Dibyendu Mondal, Assistant Professor of Mechanical Engineering Department of Greater Kolkata College of Engineering and Management under JIS Group. In this pandemic situation, I am delivering my lecture through online mode and my video is uploaded in YouTube. Good morning. Today, I am discussing the numerical problem of centrifugal pump. The internal and external diameter of the impeller of a centrifugal pump are 200 mm and 400 mm respectively. The pump is running at 1200 rpm. The vane angle of the impeller at inlet and outlet are 20 degree and 30 degree respectively. The water enters the impeller radially and velocity of flow is constant. Determine the work done by the impeller per unit weight of water. D1, so that is equal to 200 millimeter and that is equal to 0.20 meter. External diameter of the impeller D2, that is equal to 400 millimeter, 0.4 meter. Speed N is equal to 1200 rpm. Vane angle at inlet theta is equal to 20 degree. Vane angle at outlet phi is equal to 20 degree. Water enters radially means alpha is equal to 90 degree. Vw1 equal to 0. Velocity of flow Vf1 is equal to Vf2. Tangential velocity of the impeller at inlet and outlet are u1 is equal to pi d1n by 60 and u2 that is equal to pi d2n by 60. So pi into 0.4 into 1200 by 60. So that is equal to 25.13 meter per second. From inlet velocity triangle, tan theta is equal to Vf1 by u1. Vf1 is equal to 12.56. Vf1 by 12.56. Vf1 is equal to 12.56 tan theta. So 12.56 tan 20 degree. 4.57 meter per second. Vf2, so that is equal to Vf1 4.57. First one you have to draw the diagram first. Okay, U1 that is the inlet and U2 that is the outlet. Okay, U2, so U1 is equal to pi d1. One is the inner diameter, another one is the d2n pi d2, so that is the outer diameter. Vf1 tan theta, actually tan theta that is equal to Vf1 by u1. Vf1 by 12.56. So Vf1 is equal to 12.56 tan theta. 12.56 into tan 20 degree. 4.57 meter per second. Vf2 is equal to Vf1 equal to 4.57 meter per second. From outlet velocity triangle tan phi Vf2, so that is equal to u2 minus Vw2. So 4.57 over 25.13 minus Vw2. So 25.13 minus Vw2, so that is equal to 4.57 divided by tan phi. 4.57 by tan 30 degree equal to 7.915. Vw2 is equal to 25.13 minus 7.915. So that is equal to 17.215 meter per second. The work done by impeller per kg of water per second is given by the equation 1 by 8 Vw2 U2. So 17.215 into 25.13 divided by 9.81. 44.1 Newton meter per Newton. A centrifugal pump to discharge 0.118 meter cube per second at a speed of 1450 rpm against a head of 25 meter. The impeller diameter is 250 mm. Its width at outlet 50 mm. Manometric efficiency is 75%. Determine the vane angle at the outer periphery. Vane angle at the outer periphery of the impeller. So previous problem, first one you have to draw the diagram first. Okay, you have to draw the diagram first. Q is equal to 0.118 meter cube per second. Speed is equal to 1450 rpm. HM is equal to 25 meter. Diameter at outlet T2 is equal to 250 millimeter, that is equal to 0.25 meter. B2 is equal to 50 millimeter, 0.05 meter. Manometric efficiency, that is equal to 75%, 0.75. Let the vane angle at outlet, so that is equal to phi. Now U2, so that is equal to pi d2n by 60. Pi into 0.25 into 1450 by 60. So that is equal to 18.98 meter per second. Discharge is given by Q is equal to pi d2 b2 into Vf2. So Vf2 equal to Q by pi d2 b2. 0.118 over pi into 0.25 into 0.05. So that is equal to 3 meter per second. Manometric efficiency GHM by VW to U2 9.81 into 25 divided by VW2 into 18.98. VW2, that is equal to 9.81 into 25 eta mano into 18.98. So 9.81 into 25 and 0.75 into 18.98, 17.23. So from the outlet velocity triangle, tan phi is equal to Vf2 by U2 minus Vw2. Now Three point zero divided by 18.98 minus 17.23, 1.7143. Phi is equal to tan inverse 1.7143, 59.74 degree or 59 degree 44 minute. A centrifugal pump delivers water against a net head of 14.5 meter and a design speed of 1000 rpm. The vanes are curved back to an angle of 30 degree. With the periphery, the impeller diameter is 300 millimeter. The outlet width is 50 millimeter. Determine the discharge of the pump if manometric efficiency is 95%. Net head is equal to 14.5 meter hm. Speed is equal to 1000 rpm. Vane angle equal to vane angle at outlet phi is equal to 30 degree. Impeller diameter means the diameter of the impeller at outlet. D2 is equal to 300 millimeter. That is equal to 0.3 meter. Outer width B2 50 millimeter. That is equal to 0.05 meter. Manometric efficiency eta mano 95%. That is equal to 0.95. Tangential velocity of the impeller at outlet U2 is equal to pi d2n by 60. 0.3 into 1000 by 60, 15.70. Now using the equation, manometric equation GHM by VW2 by U2. তাহলে 9.81 into 14.5 VW2 into 15.70. তাহলে VW2 is equal to 0.95 into 14.5 divided by 0.95 into 15.70. So that is equal to 9.54 meter per second. So tan phi VF2 divided by U2 minus VW2 or tan 30 degree, that is equal to VF2 15.70 minus 9.54. So VF2 6.16. তাহলে VF2 that is equal to 6.16 into tan 30 degree. So that is equal to 3.556 meter per second. So therefore discharge Q that is equal to pi d2 V2 into VF2 pi into 0.30 0.05 3.556. So 0.16575 meter cube per second. A centrifugal pump having outer diameter equal to 2 times the inner diameter and running at 1000 rpm works against a total head of 40 meter. The velocity of flow through the impeller is constant and equal to 2.5 meter per second. The vanes are set back at an angle of 40 degree at outlet if the outer diameter of the impeller is 500 millimeter and width at outlet is 50 millimeter. Determine the vane angle at outlet. Work done by impeller on water per second and manometric efficiency. N is equal to 100 rpm. You draw the diagram first, then VR1, U1, VF1, another one is the V2, VR2, U2. N is equal to 1000 rpm, HM is equal to 40 meter, VF1 is equal to VF2 is equal to 2.5 meter per second, phi is equal to 40 degree, D2 is equal to 500 millimeter, 0.5 meter. Inner dia of impeller D1 that is equal to D2 by 2, 0.25 meter. Width at outlet B2 that is equal to 50 millimeter, 0.05 meter. Tangential velocity of the impeller at inlet and outlet are U1 is equal to pi d1n by 60, pi into 0.25 into 1000 by 60, 13.09 meter per second. u2 is equal to pi d2n by 60, তাহলে pi into 0.50 into 1000 by 60. Discharge is given by q is equal to pi d2 b2 into vf2, pi into 0.5 into 0.5 into 2.5, 0.1963 meter cube per second. From the inlet velocity triangle tan theta, that is equal to Vf1 by u1, that is equal to 2.5 by 13.09, equal to 0.191. So theta is equal to tan inverse 0.191. So that is equal to 10.81 degree or 10 degree 48 minutes. Work done by impeller on water per second is given by W by G into VW to U2, rho GQ G by G into VW to U2. So 1000 into 9.81, 1000 into 9.81 into 0.1963 by 9.18 into VW2 into 26.18. But from the outlet velocity triangle we have tan phi, that is equal to Vf2 by U2 minus VW2. So 2.5 26.18 minus VW2. So 26.18 minus VW2, 2.5 by tan phi, that is equal to 2.5 by tan 40 degree. So 2.979. VW2, that is equal to 26.18 minus 2.979, 23.2 meter per second. Substituting this value of VW2 in equation, work done 1000 into 9.81 into 0.1963 by 9.81, 23.2 into 26.18, so 11927.9 after calculating VW2, that is equal to Newton meter per second. Now manometric efficiency, actually when you calculate the manometric efficiency you have to follow the formula GHM by VW2U2. So 9.81 into 40 divided by 23.2 into 26.18, 0.646, 64.4%, that is the answer. Centrifugal pump discharges 0.15 meter cube per second of water against a head of 12.5 meter. The speed of the impeller is being 600 rpm. The outer and inner diameter of the impeller is 500 millimeter and 250 millimeter respectively. Now 250 millimeter respectively and bent at 35 degree angle. Area of flow 0.7 meter square from inlet and outlet. Calculate manometric efficiency of a pump. So Q is equal to 0.15 meter cube per second. HM 12.5, 1 by 1 you write down. N is equal to 600 rpm. Now draw the diagram and try to solve. Okay, diagram first and try to solve. Okay, thank you. Last, if you like my video, you have to subscribe. Okay, thank you.